Hey, Intensified Algebra kids, Mr. McCrossin here with your weekly lesson. Okay, today we are going to do some teaching on solving systems with elimination. We've done some teaching now with solving with graphing, where you see where the two lines cross. Well, there's another method you can do, and it's an algebraic method, and it's called solving using elimination. So I'm gonna have my beautiful camera holder come on over here. So when we're solving with elimination, okay, there's two different types of problems you can have. One, you look for opposites. If you have opposites, you can just go and straight solve. The other one is if you don't have opposites, and we'll talk about kind of what opposites mean here in a second. But if you don't have opposites, you have to create opposites through multiplication, and then you can solve. So an example of a problem that has opposites is like a 2x and a negative 2x. Those are opposite of each other, positive, negative, so they would cancel. I would be able to solve this using elimination. The other way is if we have one here where it is a 2x and a 4x. Well, 2x isn't the opposite of 4x. So I'd need to multiply this by negative 2 to make that a negative 4x, and now I have opposites. So I would have to create opposites through multiplication to be able to solve, because we have our goal here, and our goal is always with elimination. Who would have guessed that we want to eliminate one variable? So I'm going to walk us through three different equations, okay, and we're going to go from there. So the first equation is like that step one, okay, and can you see that okay? All right, perfect. So here I'm super lucky because it says 2x plus 3y equals 76. And the other one is negative 2x plus 5y equals 20. So I have opposites. My opposites are the negative 2 and the positive 2x. So what I can do is draw a line underneath these and just add them straight down. 2x minus 2x, those cancel. I have nothing. 3y plus 5y is 8y, and 76 plus 20 is 96. Well, now I have this equation. I've eliminated my one variable, which is awesome. Good job, guys. We've eliminated that variable. Okay, so now what I can do is I can divide by 8. Well, why'd you divide? Well, it's 8 times y, so the opposite of multiplication is division. So I'm going to divide this by 8. So this becomes y equals a dozen. Y equals 12. Cool. But McCrossin, you might be asking, don't we need an x? If we have a y, don't we also need an x? You're right. So what I'm going to do is I'm going to take this equation. You can take either equation. I just like this one a little bit more. Okay? So I'm going to... Actually, I lied. I like the other equation a little bit better. So what I'm going to do is I'm going to plug in this y into y in that equation. So I'm going to take that equation, 2x plus 3y equals 76, and I'm going to take this 12 and plug it right in there. All right, cool. So now I would get 2x plus 3 times 12 equals 76. 2x plus 36 equals 76, minus 36, minus 36, cancel, 4. 2x equals 40, divide by 2, divide by 2, x equals 20. So my final equation, or my final solution in an ordered pair, remember ordered pairs are x, y, so my final solution is the point 20, 12. And if we were to graph these two lines, that is where they would cross on the map, on our graph. And so that's one way to solve it algebraically. So that's a pretty easy example. So I'm going to go ahead and erase this, and we'll do our next example. So here's our next example I got for us. I have 4x, can you see that okay on the camera? plus 5y equals 22, and 4x plus 3y equals 18. Okay, you might say, McCrossan, we have opposites right there, 4x and 4x. Well, they're both positive. You have to have one be positive and one be negative. So what I'm going to do here is I'm going to multiply. I'm going to create opposites through multiplication. I'm going to multiply this whole bottom one by -1. So I'm going to multiply -1 by that, -1 by that, and -1 by that. I'm going to multiply by -1. I didn't change this top equation. That stays the same. 4x plus 5y equals 22. But now -1 times 4x is -4x. -1 times 3y is -3y. And -1 times 18 is 18. So now I have, -18. -1 times 18 is -18. So now, all of a sudden, I've created my opposites right here. I created them through multiplication. So I'm going to go ahead and add these like I did before. I'm going to add them straight down. Those cancel. 5y minus 3y is 2y. And 22 minus 18 is 4. Divide by 2. Divide by 2. Y equals 2. I'm going to take my equation from up here. 4x plus 5y equals 22. I'm going to plug that in for y. And I get 4x plus 5 times 2 equals 22. 4x plus 10 equals 22. Minus 10, minus 10. And I would get 4x equals 12. Divide by 4, divide by 4. X equals 3. Final point. 3, 2. And if I were to graph those again, you can always double check these by going onto Desmos and typing these equations in and seeing if they cross at that point. If they don't cross at that point, then either A, you typed in your equations wrong on Desmos, or B, you did a math error in here. There's a math error somewhere in there and you got to double check it. Okay, we're going to go into the last example, and that's our hardest example that we have, okay? And that's if the numbers don't match. So I have this really good example here. I've been staring at the light on my camera, so I can't really see it. Here we go. 2x plus 9y equals 12. And 4x plus 3y equals -6. Okay. Here, I need to create opposites, but you might notice, man, these numbers aren't even the same, let alone opposites. So, okay, let's create some opposites. I have a positive 4. I'll check this. Yep. I have a positive 4, and I have a positive 2. I've got a positive 9 and a positive 3. I'm gonna try and eliminate my x's because I gotta eliminate one of the variables. You can eliminate your y's too if you wanna do that. Your multiplication would just look different. But if I'm trying to come up with the opposite of positive 4, I need this to be a -4. So I'm gonna multiply everything up here. Well, 2 times what is -4? 2 times -2. So I'm gonna multiply everything on top by -2. So I'm going to multiply that by -2, multiply that by -2, and I'm going to multiply that by -2. Multiply everything. Remember, when you do this multiplication, you have to multiply everything, not just the 2, everything in that top equation. So I get negative 4x minus 18y equals negative 24. I didn't change this bottom equation. 4x plus 3y equals negative 6. From here, I've just created my opposites right here. By multiplying the whole top equation by negative 2, I have the opposite of 4. So I created the opposites, those cancel. Negative 18 plus 3 is negative 15y. Negative 24 plus negative 6 is negative 30. I'm going to divide by negative 15, divide by negative 15, y equals 2. Now I'm going to use my equation, 4x plus 3y equals negative 6. I hope I didn't lose you guys over here when I talked about negative 30 divided by negative 15. We all know two negatives makes a positive. So here I plug this in for my y. 4x plus 3 times 2 equals negative 6. 4x plus 6 equals negative 6 minus 6 minus 6. 4x equals negative 12. Divide by 4, divide by 4, and x equals negative 3. Final answer, negative 3, 2. So guys, in summary, when you are using elimination, it's an algebraic method, meaning you don't need graphs, you don't need tables, you don't need anything. You can just do the math, all right? And you have two different types of cases. Either you look for opposites, and if you have them, you can go right into this solving process. Otherwise, you have to create your opposites, and then you can solve. I hope you guys took notes on this video. There is an associated Go formative with it. Remember to do my check-ins on Wednesdays, and I miss you guys a ton. I hope you guys are staying safe. Later.